So there are like a lot of different permutations or types of questions you can ask by putting together the Ka equation and the Kw of water and the pH plus the pOH and things like that. For example, one question about an acid which shall remain nameless, because I'm going to make the math really easy here, is they could conceivably give you the pH and they could then tell you what the Ka is and say, okay, what was the initial concentration? Like, what's the concentration of HA, right? Now, the good thing is we know if, now again, this has to be just a pure aqueous solution of this weak acid. If there's other things there, that can cause equilibrium shifts. We can have a common ion situation and stuff like that. But because this is just water and this weak acid, it's an easy thing to do. Because the pH is 4, okay, and the Ka is 10 to the minus 6, we know a lot. What we do know is we know the H plus concentration is 10 to the minus 4. And we can assume, because all weak acids do the same thing, that we know the concentration of the A minus as well, because these two things, the H plus and the A minus, should be equal to each other. So therefore, if we know the H plus, we also know that A minus is 10 to the minus 4 as well, and therefore we can then plug those into the equation. So on the top here, we're going to put 10 to the minus 4, and then we're going to put the other 10 to the minus 4. And on the bottom, we're going to do x minus 10 to the minus 4. Now, we're going to, again, make the assumption that whatever the concentrations was, in all likelihood, this value of 10 to the minus 4 is insignificant compared to x. But again, if you have a calculator and you want to include the 10 to the minus 4 in there, you're actually welcome to do that. So in this particular calculation, what I'm going to do is I'm going to do the approximate equal sign, and we can always check the assumption later to see that's a less than 5%. And so we basically have 10 to the minus 4 times 10 to the minus 4 over x is equal to 10 to the minus 6. And so when you do the math, you end up with 10 to the minus 6 equals 10 to the minus 8 over x. And again, of course, the math could be more difficult. That's minus 8. And so we find that x is equal to 10 to the negative 2, which is equal to which is equal to 0.01. So we can assume the original that is equal to the original that is equal to HA, and we can check our assumption here by looking at check the percent ionization. And if we do that, we're basically putting 0.0001, which is 10 to the minus 4, over 0.01, which is this. So we're putting this underneath this, which is on the top, and timesing that by 100. And this is the type of math you should kind of be able to do in your head. Basically you end up with 1%, which means your assumption is good. Yep, that's it. Short and simple.